Greetings. Since we already covered for power distribution of FM and generation and demodulation in FM, let's proceed with the next part in angle modulation part 2, which is noise in FM. Noise is interference generated by lightning, motors, automotive ignition systems, and power line switching that produces transient signals. Noise is typically narrow spikes of voltage with high frequencies. Noise, voltage spikes, add to a signal and interfere with it. Some noise completely obliterates signal information. In AM systems, noise easily distorts the transmitted signal. However, in FM systems any added noise must create a frequency deviation in order to be perceptible. Maximum frequency deviation are caused by random noise occurs when the noise is at right angles of the resultant signal. In the worst case, the signal frequency has been deviated by delta equals theta FM. This shows that the deviation due to noise increases as the modulation frequency increases. Since noise power is the square of the noise voltage, the signal-to-noise ratio can significantly degrade. Noise occurs predominantly at the highest frequencies within the baseband. FM signals have a constant modulated carrier amplitude. FM receivers contain limiter circuits that deliberately restrict the amplitude of the received signal. Any amplitude variations occurring on the FM signal are effectively clipped by limiter circuits. This amplitude clipping does not affect the information content of the FM signal, since it is contained solely within the frequency variations of the carrier. Figure 1 shows an FM signal with noise, pre-emphasis and the emphasis. Noise can interfere with an FM signal and particularly with the high-frequency components of the modulating signal. Noise is primarily sharp spikes of energy and contains a lot of harmonics and other high-frequency components. Therefore, to overcome high-frequency noise, a technique known as pre-emphasis is used. In this technique, a simple high-pass filter can serve as a transmitter's pre-emphasis circuit. Pre-emphasis provides more amplification of only high-frequency components. Figure 2 shows the pre-emphasis circuit. The formula for pre-emphasis circuit is Fc equal to R1 plus R2 over 2 pi R1 R2C. A simple low-pass filter can operate as a de-emphasis circuit in a receiver. A de-emphasis circuit returns the frequency response to its normal flat level. The combined effect of pre-emphasis and de-emphasis is to increase the signal-to-noise ratio for the high-frequency components during transmission so that they will be stronger and not masked by noise. Figure 3 shows the de-emphasis circuit. The formula for de-emphasis circuit is Fc equal to 1 over 2 pi Rc. Below. Since we already covered all the subtopic in part 2 for angle modulation system, let's learn more about how this knowledge are applied. FM is commonly used at VHF radio frequencies for high-fidelity broadcasts of music and speech. FM broadcasting. Normal, analog, TV sound is also broadcast using FM. The type of FM used in broadcast is generally called wide FM, or WFM. A narrowband form is used for voice communications in commercial and amateur radio settings. In two-way radio, narrowband narrow FM, NFM, is used to conserve bandwidth. In addition, it is used to send signals into space. These are several examples of major applications for frequency modulation and amplitude modulation. The advantages of angle modulation. The disadvantages of angle modulation.